The Jillbeck way.
Welcome to the Jillbeck way, where I take science problems and I turn them into math problems. All right, a gas that has a volume of 28 liters, a temperature of 45 degrees Celsius, and an unknown pressure has its volume increased to 34 liters and its temperature decreased to 35 Celsius. If I measure the pressure after the change and it's 2 atm, what was the original pressure of the gas? All right, so set myself up a box of knowledge where I have my 6 unknowns here. I have P1, V1, T1, and then I have P2, V2, T2. Hello? Make my box a little bit bigger. So, from here, I'm going to pull out all the information from this word problem into my box of knowledge here. Because something about word problems gets you guys a little afraid. So we're just taking the information out of this verbiage and putting it into our substitution box. So, volume of 28 liters. That's our initial volume, right? These are not exponents, right?
No.
Right. So, our initial volume is 28 liters. Our temperature, 45 degrees Celsius. And an unknown pressure. Don't know? Question mark. Then, the volume was increased to 34 liters, and its temperature was decreased to 35. Volume 2 is 34 liters, temperature 35 degrees Celsius. If I measure the pressure after, so final pressure, pressure 2, is 2 atm. We are solving for P1 here. Now, in our box of knowledge is where we check our units. Are our volumes in the same unit? Both of them are liters, it'll work. What do we have to make sure our temperature is? Kelvin. So we have to turn these into Kelvin. And in order to take Celsius to Kelvin, you add
273.
273. So 45 plus 273 is, calculators, mathematic helpers, 273.
318.
318 Kelvin. T2, 35 plus 273.
308.
308. Now that we've done all of this, take it back to the good old plug and chug, and you are taking these new measurements, calculations that we pulled from the problem, and all you are is plugging it into what you know. So we have no idea what P1 is, correct?
Correct.
That's our variable. Of course, me being an algebra teacher, I like to use a whopping X. Volume 1, 28. Except, I don't like writing it like this. What do I like writing it like?
28x.
Over, what's our T1?
318 Kelvin.
318 equals 2 times 34 over 308. Now, there are multiple ways to solve from here. Simplify what we know. What is 2 times 34?
68.
We can now cross multiply and solve this like a proportion. You've been solving the proportions since what? 6th grade? 5th grade? 6th grade? 5th grade? Solve it like a proportion. What's 68 times 318?
21,624.
Oh my gosh, 21,624 equals, what is 308 times 28x?
8,624x.
X. This is a one-step equation. Divide both sides by 8624. And you're missing X or your
2.2.
initial pressure. Pressure is what?
2.507.
Oh my gosh, 10th place. Give me 10th place.
2.5.
2.5 ATM. Boom.